Combustion reactions. We've probably all heard of them and have the idea that they release heat, but beyond that, the understanding may get a bit unclear. They seemed like such an important thing in our chemistry classes growing up, but after that, you probably didn't hear much about combustion reactions in a casual setting. Today's video is going to explain how combustion reactions play a huge role in all of our lives while keeping a relatively low profile. To begin, there are two main types of combustion reactions: complete combustion and incomplete combustion. Complete combustion has some type of fuel and oxygen as the reactants, and carbon dioxide, water vapor, and heat as the products. Meanwhile, incomplete combustion has the same reactants, but the products are carbon monoxide, water vapor, heat, and carbon in the form of soot. Looking at the two sets of products, you can probably guess which type of combustion is more preferred. It's complete combustion. It has to be complete combustion. While incomplete combustion produces less energy, the main reason why it's less desirable is because it produces carbon monoxide, which is quite dangerous to humans. Because of this, while designing different things that use combustion reactions, engineers and designers spend a great deal of time and energy making sure complete combustion is achieved as much as possible. It's great that we know the difference between complete and incomplete combustion, but where can we actually see these reactions in reality? One of the most widely used applications of the combustion reaction is in the internal combustion engine. So when you fire up that vehicle of yours, you're using the energy created by a combustion reaction as a mode of transportation. But what is the actual reaction? Well, if you're using a vehicle that runs on gasoline, the reaction looks kind of like this. We have 2 parts octane, 25 parts oxygen, and that's going to produce 16 parts carbon dioxide, 18 parts water, and some energy in the form of heat. So from this reaction, we can tell that complete combustion is achieved as we have the products of carbon dioxide, water vapor, and energy. This is no mistake, as there is a ton of intricate calculations to get the fuel to air mixture just right. If this ratio is just a bit off, it can result in what's called a rich or a lean mixture. If a gasoline-powered vehicle is running on a rich mixture, it means that some of the fuel is going unburned. In simple terms, too much fuel, not enough air. This can lead to incomplete combustion taking place and will show signs such as black smoke coming from the exhaust and carbon monoxide being produced. It can be caused by an airflow sensor malfunction or a faulty fuel injection system. On the contrary, a vehicle can also run a lean mixture, which is when there's too much air for all of the octane to react with. This can lead to decreased fuel efficiency and even an engine knock if the problem persists for long enough. So if there are all of these potential issues with the ratio of fuel to air in vehicles, what are vehicle manufacturers doing to make sure the mixture is just right? The main thing being done is companies are always improving their oxygen sensors on their vehicles. The job of these is to maintain the 14.7 parts air to 1 part fuel ratio for an engine to maximize the efficiency and power of the engine. They work by comparing the oxygen content in the ambient air to the oxygen content in the exhaust fumes. A signal based on this reading is then transmitted to the engine control unit, and it adjusts the ratio of air to fuel accordingly. Now, even with a fine-tuned oxygen sensor, an engine will not always be running complete combustion because of the constant change in work that an engine must do to stay in the flow of traffic. As a result, carbon monoxide will sometimes be a product from running an engine. But how do vehicle manufacturers stop this from getting into the environment? This is where a catalytic converter comes into play. It's a device located between a vehicle's engine and exhaust tip meant to convert carbon monoxide and other harmful substances to less dangerous products before they're expelled from a vehicle. They also contain valuable metals that help with the breakdown of nitrogen oxides, which is unfortunately why it's become such a popular thing to steal off of vehicles. But with these oxygen sensors and catalytic converters, vehicles powered by internal combustion engines have become quite efficient and clean compared to pre-1975, when catalytic converters became mandatory on all new vehicles. So yes, we may take our vehicles or other modes of transportation for granted, but it's worth noting the amount of research and development that goes into the production of these vehicles. Being able to get the fuel to air ratio just right for the vast majority of time an engine is running is a huge accomplishment on its own. But then to also stop the small amount of carbon monoxide produced from being released into the atmosphere, well, that's just amazing. So if you like this video, be sure to like and subscribe, and if you have any ideas for my next, drop a comment below. Thank you very much.
3, 2, 1, 0, and liftoff of Space Shuttle Atlantis on a mission to build, resupply, and to do research on the International Space Station.